Okay, so we're factoring a trinomial with three terms of this form where we have 1 on the x squared, so there's no 2 or 3 or 4. Some number times x and then some number besides that. What we want to do is we want to find these two numbers, so we're going to have x and x as our first terms. And these two numbers we find so that these two add up to b, and they multiply to c. So for example, when we're trying to factor x squared plus 7x plus 12, we're going to start with x and x, and we want to find two numbers that add up to 7 and multiply to 12. Okay, so if we do 3 and 4, 3 plus 4 is 7 and 3 times 4 is 12, that will work. Okay, and the way to check this is to use FOIL. So to FOIL this, we get x squared plus 4x plus 3x, that gives us 7x, and then plus 3 times 4 is 12. Okay, so let's look at a couple more examples. So let's try to factor x squared minus 2x minus 3. So we would start by starting with x and x to get that x squared on our first. And then we're looking for two numbers that add up to minus 2 but multiply to minus 3. So if you do minus 3 and plus 1, those add up to minus 2. And if you multiply those, you get minus 3. So that would be our factorization for that. And if we FOIL that, we'd see that that happens. Now this one, b, is a little bit different because we have, notice this is called quadratic form, but we don't have an x here. We have actually a 5a plus 1, and we have it squared here, and then we have minus 2 times that here. So what we can do is kind of make a substitution, and we can call this, we can call it u. So let's put a u here, okay, and a u here, and u, okay, and u represents 5a plus 1. So when we factor that, we get u minus 3 times u plus 1, okay? And then we can substitute back over here. So down below we could write that as 5a plus 1. And then in this box we can write 5a plus 1. So when we substitute back, we're going to have 5a plus 1 in here and 5a plus 1 here, and this is our factorization. So instead of u minus 3 and u plus 1, we have 5a plus 1 minus 3 and 5a plus 1 plus 1. And we simplify those, we get 5a minus 2 and 5a plus 2 here. Okay, so we did a substitution there because we can factor this if this were a single variable, right, as a quadratic. So that's what we do, is we substitute this for u and this for u to do that. Okay, so let's look at our special factoring formulas. One of the most important ones that we use is called the difference of squares, and that's where you have an a squared minus b squared. Okay, some quantity squared minus another quantity squared, and that's just a minus b times a plus b, which we've already talked about, right? Okay. We talked about perfect squares, so a plus b squared is a squared plus 2ab plus b squared, and a minus b squared is a squared minus 2ab plus b squared. We didn't talk about this yet, but difference of cubes. This is when you're taking a cube minus a cube. So a cubed minus b cubed is a minus b times a squared plus ab plus b squared. And then a cubed plus b cubed, the sum of cubes, is an a plus b times a squared minus ab plus b squared. Okay. Now, notice these have the same format, except this, for minus, the minus goes here and the plus goes here. And for plus, the plus goes here and the minus goes here. So these follow the sign of this, and these don't. Okay, that's the only difference there. Okay, and then I'm going to ask you to memorize the difference of squares. I will give you the formula for difference in sum of cubes on a test or quiz, but you should know this one, number 1 at least. Okay, and then of course 2 and 3 because you're going to FOIL those. Okay, so let's look at some examples. This is difference of cubes here. Now notice 1 is a cube because 1 times 1 times 1 is 1, right? This is also a cube because this x cubed is a cube, but also the number part has to be a perfect cube also, and 3 times 3 times 3 is 27. So if the number is not, if the coefficient, the number part is not a perfect cube, then this term is not a perfect cube. So both parts have to be perfect cube, this and this. Now we know it's a perfect cube because the exponent is a multiple of 3. So anytime your exponent is a multiple of 3, it's a perfect cube. Okay. There's a perfect cube too. Okay, so we use difference of cube formulas with a equals 3x. That would be our a cubed. So 3x cubed is 27x. 3x quantity cubed is 27x cubed. And our b is 1. So we're going to do a minus b. Okay, so this is a cubed minus b cubed. Okay, so 3x cubed minus 1 cubed is a minus b times a squared plus ab plus b squared. So I'm showing you where the parts are, from that formula. So that would be 3x minus 1. This is 9x squared. This is plus 3x, and this is plus 1. So we simplify, inside these parentheses. Okay, and this one, we can't use squares. This is a perfect square, but it's a sum anyway. But this is not a perfect square, so we couldn't do that anyway. But this is a sum of cubes formula. Okay, so we have, this would be x squared cubed, and this is 2 cubed. So we figure out what the a and b are. What cube gives us this, and what cube gives us that. Okay, so here our a is x squared, and our b is 2. So a cubed plus b cubed would be a plus b, so x squared plus 2. Times a squared, now our a is x squared, so a squared, x squared squared is x to the 4th, minus ab, so minus 2 times x squared, plus b squared, so our b is 2, square that, you get 4. Generally, you're not going to be able to factor this trinomial that you get when you use your difference or sum of cubes formula. Okay, this comes from our earlier formulas where we're taking a plus b squared, so this is actually a plus b squared, and this is a minus b squared. Okay, so we have a plus b squared, we have a squared plus 2ab plus b squared, and we have a minus b squared, we have a squared minus 2ab plus b squared. Remember, we can't do a squared plus b squared, it's not the same thing, right? So what we recognize here, though, is that we've got 2 times this multiplied plus, or 2 times this multiplied minus is our middle term, okay, when we have these perfect squares. This is why we call these perfect squares, because we're squaring this a plus b, and we're squaring the a minus b. Okay, so we recognize a perfect square if the middle term is 2ab or minus 2ab. Okay, so here's an example where we're recognizing a perfect square. So x squared plus 6x plus 9, here our x is, a is x and our b is 3, and notice that's 3 squared, and this is a times b, okay? So, or 2 times a times b. So 2ab is 2 times x times 3, which is 6x. Okay, so the middle term is 6x. So this is a perfect square. We could write this as x plus 3 squared. We could also just try to factor as a trinomial to get that, using our FOIL and reverse. Okay, and we're also going to try to factor this, 4x squared minus 4xy plus y squared. Now we also recognize that as a perfect square. So here our a is 2x and our b is y, and our 2ab would be 2 times 2x times y, which is 4xy. So this 4x squared minus 4xy plus y squared would just be 2x a minus y b squared. Okay, we could do this by kind of doing FOIL and reverse too. And another way to look at this is we can kind of look at it like this. If you set your y equal to 1, you have 4x squared minus 4x plus 1, right? And we can factor that as 2x minus 1 squared. So this is kind of like an expanded version of this thing, where this is a perfect square. But if you put a y here, you're going to get a y there, right? Okay. You're going to get y squared there, right? So, so that's the idea, is that we're kind of looking at sort of an expanded version of this thing with an extra variable thrown in at the end, okay, of a y there. And that's how we get the y in the middle term as well. So in general, we're going to factor out common factors first, then check the result to see if we can factor any further, okay? And we repeat that until we have factored completely, okay? So we want to kind of go through the process by first looking at common factor, greatest common factor, factor that out, then see if we can factor anything further. And then we get factors, see if we can factor those down. So we're trying to get everything into prime factors, which means we can't factor them anymore. Okay, let's look at this first example. We're trying to factor 2x to the 4th minus 8x squared. Now we have common factor in both of these. 2 goes into 2 and 8. And then look at the x. The lowest power of x is 2, so x squared goes into both of those. So we have a common factor of 2x squared. And we divide it out of these two, we get x squared divided by 2. If we take 2x squared out of 2x to the 4th. And if we take 2x squared out of this, we get minus 4. Okay, so there's our what happens when we factor out the common factor of 2x squared. But notice we can still factor this further because this is a difference of squares. So this would be x minus 2 times x plus 2. Okay, so there's our last step, is that we factor that. Okay, now it's factored completely. Okay, let's look at part B of that problem. So we're trying to factor out x to the 5th y squared minus xy to the 6th. Let's look for the greatest common factor first. So we have an x in both terms. The smallest power is 1, so we're going to factor an x out of both of these. And then for the y, we have y in both terms, and the smallest power of y is y squared, so we're going to factor out an xy squared. Okay. So when we do that, divide xy squared here, we get x to the 4th. And we divide xy squared here, we get y to the 4th. Now this is a difference of squares. Okay, so now we have x squared minus y squared squared. So here's our greatest common factor. Now we take the difference of squares, we get this. So here our a is x squared and our b is x squared, difference of squares. So we're going to take a plus b, x squared plus y squared, times a minus b, x squared minus y squared. And then notice now we can't factor a sum of squares. Okay, there's no factorization for that. But we can still factor this one, this x squared minus y squared, because it's a difference of squares again. So this would become x plus y times x minus y, and then this carries down and this carries down. So there's the complete factorization of that. Okay, the last thing we're going to look at in this section is factoring by grouping. So basically when you have more than 3 terms, you can group your terms, so you can try and factor them in groups. So a natural way to start would say, let's make the first 2 one group and the second 2 another group, and we'll try to factor those separately. Okay? So for this one, we can say, let's find a common factor in these 2, which would be x squared, right? And let's try to find a common factor in these 2. So we're going to break this thing into this group of the first 2 terms, and the second 2 terms are in another group. So for the first group, we can factor out an x squared, and we get x squared times x plus 1. The second group, we can factor out a 4, so we get 4 times x plus 1. And then notice when we do that, we have a common factor of x plus 1 in between the 2 groups. So we can factor out that x plus 1 on both of these. Okay? And that would give us our final factorization of x plus 1 times x squared plus 4. Okay? I can't factor this any further because it's a sum of squares, not a difference of squares. Okay, so that's factoring by grouping. If that doesn't work, you can always regroup them. So let's try these 2 or these 2, or however you want to group them. But generally, naturally, you'd start with the first 2 as a group, and then maybe the second 2 as another group. Okay, fine. For our last example, we have 4 terms here, and let's group them kind of the way we did before. These first 2 will be a group, okay, and then these last 2 will be a group. Be careful because you have a negative in between your 2 groups, right? So if you're going to put a minus here, then it should be 3x minus 6 in the parentheses, not 3x plus 6, because think about what this, we have a minus 3x here and a plus 6 here. If we put a minus in front of this parentheses and we want to have a plus 6 eventually, ultimately, then we have to put a minus in there. So be very careful with that. It's easy to mess up the signs in that group if you have a minus in between your groups. Okay? So this would be minus 3x minus 6 in parentheses. Okay. And then, so here we have a common factor of x squared in the first group. So that would be x squared times x minus 2. And then we can factor out a 3 in this group. So that would be minus 3 times x minus 2. Right. Okay. And then notice we have a common factor of x minus 2 in both those groups. So that would be x minus 2 times x squared minus 3. Okay. And we're done because this is not a difference of squares, right? 3 is not a perfect square. Okay? So that's the end of section 1.3.